profiling the latest cutting-edge developments in science. Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, we're going to talk about the SETI project, the search for extraterrestrial intelligence. We're going to talk about aliens from outer space. With us today is a PhD physicist, Seti Shostak, who's one of the directors of the Seti Institute in Mountain View, California, whose profession is to search thousands of stars in outer space for signals from intelligent alien civilizations. He got his bachelor's in physics from Princeton, PhD in astrophysics from Caltech, and he's with the Seti Institute. And so today we're going to talk about something that, well, Hollywood has been fascinated about. Think of the movies, all the big thrillers of the movies. Many of them have been centered about space travel, about encountering aliens from outer space. But have you ever thought afterwards, well, what's the science? What's the science behind all that? Can we really believe all these stories that we hear in Star Wars and Star Trek? Well, that's why we brought a physicist along with us today from the Seti Institute. And just remember, the Seti Institute operates one of the largest collection of radio telescopes specifically dedicated to search for signals from an intelligent civilization in outer space. How do they do it? Well, they have radio telescope antennas that sift through all the static we get from the stars, and among the static, we hope to find regular signals. Signals like Morse code, for example, signals like digital, signals that cannot be random. So far, after going through decades worth of data from thousands of stars in outer space, they have found nothing. But one day when they do find the first signal from an intelligent civilization, it'll change human history. It'll be bigger than the invention of fire. Think about it. An intelligent civilization, perhaps more advanced than us, found in outer space. And Arthur C. Clarke, the famous science fiction writer, once said, either there is intelligent life in outer space or there isn't intelligent life in outer space. Either thought is frightening. Well, you don't have to be frightened anymore, because with us today is a physicist who will walk through the pros and cons and all the dead ends and all the successes that we've had, creating a technological infrastructure by which we can settle once and for all the possibility of intelligent life in the universe. And then we'll say a few things about the movies. Everyone loves to go to the movies, and a good fraction of the thrillers we see in Hollywood movie theaters come from outer space. So we'll talk about the movies as to whether or not there's any science to be found when you watch the movies. And so once again, we're going to talk about the SETI project in light of the fact that the Kepler satellite has found over 3,600 planets orbiting other stars. Things that we once thought were science fiction. Things that we could only dream about. Well, we have the knowledge, the capabilities, and the abilities to nail down those facts and those experiments. The Kepler satellite has found concrete evidence of thousands of planets orbiting other star systems, and roughly 20 of them look very much like the planet Earth. So let's take a short commercial break, and after the break, we're going to continue our discussion of the search for alien intelligence in space with Dr. Seti Shostak. Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to talk about aliens from outer space, but not from a Hollywood point of view. We're going to bring on a physicist like myself, Dr. Seti Shostak of the SETI project, the search for extraterrestrial intelligence. So we're going to talk about the science, not the hype, not the Hollywood dramatization of this, but we're going to talk about the science of the search for intelligent life in outer space. Once again, our special guest today is Professor Seth Shostak of the Search for Extraterrestrial Intelligence Institute in Mountain View, California. So, Seth, glad you could be on. Science, fantastic.
It's a pleasure, Michio.
Okay, well, let's just jump right into it. First of all, the question that we always ask our guests is, how did you, as a youth, first get interested in something as bizarre as searching for intelligent life in the universe?
Well, it is bizarre in the sense that there aren't many people that actually have it as a job description. That may be like 20 people in the world. But I think that just about every kid is interested in aliens. They see them every night on television, and of course they see them in the movies, and I think that reflects their interest rather than the other way around. But the idea that there might be other beings that are just as clever as we are, or more so, out there, I think that appeals to kids in the same way that dinosaurs appeal to kids. I think they appeal because they've got big teeth. You know, there's some evolutionary advantage in being interested in things with big teeth or just other beings.
Okay, and when you were a youth, were you fascinated by science fiction, about all the tales and heroics of astronauts blazing the trail in outer space and meeting aliens?
Well, I didn't read much science fiction. I, to this day, regret the fact that I am very, very poor at knowing the science fiction literature, because I think that better science fiction ideas are actually in written science fiction. But what I did do was go to all the movies, that's for sure, and there were a lot of them when I was a kid. And I think a lot of my interest, not just in SETI, the idea of looking for intelligent critters, but my interest in science was largely stimulated by these fictional stories. Remember, in science fiction, certainly in the movie science fiction, the hero is usually the idea. And that to me was sort of an interesting thought.
Okay. Well, let's just jump right into SETI, the Search for Extraterrestrial Intelligence, and the Seti Institute. First of all, can you tell us what SETI is and say a few things about the Institute?
Yes. SETI, which is just an acronym, it's almost my name, which is by somewhat of a coincidence, but it stands for the Search for Extraterrestrial Intelligence. And the acronym was actually coined probably in the 1970s. I don't remember the exact year. But the idea is an old one. Look, there's a lot of cosmic real estate out there. Could there be other beings? Of course there could be. Well, how could we find them? Well, our rockets, can't reach them, not in any reasonable length of time. So maybe we could find signals. Now, the idea of looking for signals, that's actually a very old idea. It goes back to the American Civil War when physicists in Europe were considering looking for, flashing lights from the moon or Mars, both of which they thought could be inhabited. And, so that idea is an old one. It's been updated. It was updated in the late 1950s and the 1960s by a couple of physicists, actually, who just worked out that even at that point in history, less than 100 years after the invention of radio, it was already possible for us to build transmitters that could, send signals into space that could reach across the light years between us and the stars. So if we could do it, maybe they're doing it. Let's look for signals, and that's what we do with SETI. We look for radio signals and flashing lasers.
Okay, now let's get an update as to what's happening with SETI. I understand you have an installation at Hat Creek. I understand that Paul Allen, co-founder of Microsoft, is one of your financial backers. What's the status of how many radio telescopes you have, and are they operational at Hat Creek?
Yes, Hat Creek is a place that most people will not recognize unless they're into trout fishing, but it's a very tiny town in Northern California, about 300 miles north of San Francisco in the Cascade Mountains. And the University of California at Berkeley for many years had a radio observatory up there. They put it there because with all those mountains around and the kind of the wilderness area that it is, there wasn't much interference from either the transmitters here in the San Francisco Bay Area or from any locals. There essentially weren't any locals, right? There are a lot of cows, but not too many people. So that observatory already existed, and it was just more economical to build a new observatory there, which we did. The Allen Telescope Array, as you say, Paul Allen contributed the money to build the start of it. The idea was to build hundreds of antennas, each about 6 meters, so say 20 feet across, and we have 42 of them. We don't have hundreds yet, but that's a money thing.
Okay, and with 42 radio telescopes or so, how many stars have you analyzed, and what's the hope, given the fact there's so many stars out there, even in the night sky?
Yeah, well, that's absolutely the case. There are, after all, hundreds of billions of stars in our own galaxy, and probably the majority of them, in fact, we know the majority of them have planets. So there are an awful lot of targets out there. We tend to make lists of the nearest star systems because, after all, if they're closer by, the signals would be stronger, easier for us to detect. So how many have we looked at so far carefully over a wide range of the radio dial, a wide range of frequencies? Well, the answer to that is a few thousands, right? Not millions, not tens of thousands, not hundreds of thousands. We've looked at a few thousand, and that's not very much given how many stars are out there. And, so the fact that we haven't found a signal, I would say, is not terribly significant because we've only begun the search. But on the other hand, the equipment is getting faster all the time, so I'm very optimistic about this.
Okay, well, some people think that once we do pick up a signal from an alien civilization, it could be one of the greatest events in human history. Given that fact, you think that the United States Congress would generously fund the Seti Institute, but what's been the response from the Congress?
Well, it hasn't been entirely encouraging, actually, Michio. When I joined the Seti Institute, and that's, like 24 years ago now, that's a long time ago, it was a NASA project. In other words, there was some funding from NASA, which is to say the U.S. Congress, really, to do this experiment. And it amounted to a few $1 million a year. Now, that would be a lot of money for me personally, but it isn't very much money for a scientific experiment involving lots of people. So it was a few $1 million a year, but that was canceled by the Senate in 1993, just when the observations were beginning. In fact, it was kind of a bad time to cancel it, and it was done for political reasons. It had nothing to do with the science. But since then, there's been no funding by the taxpayer, if you will. I mean, the Congress has not told NASA, go back and do more SETI. This stop in the funding was only supposed to be for a year, but once you're out of the NASA budget, it's very hard to get back in. I just testified to Congress a couple of weeks ago in Washington to the House Science, Space, and the House Committee on Science, which is Space, Science, and Technology Committee, and they're interested, and there's at least one member of the House who's the chair of that committee who's very interested in SETI, so maybe at some point it will get back into the federal budget, but lest any listeners worry about how much that might cost them, I might point out that at the height of the NASA SETI project, it was costing each American taxpayer on average 3 cents a year, so it's not very expensive.
Okay, well, given the fact that we now have this avalanche, this incredible avalanche of data from 3,600 planets orbiting other star systems, right? Doesn't this mean that you're like a kid in a toy store? I mean, given the fact you have all these potential targets to listen for intelligent life in outer space, I mean, it's a game changer, right?
Well, it is in the sense that when I was a kid, which was quite a while ago now, but when I was a kid, I would go to New York to visit relatives, and I would go to the Hayden Planetarium on the west side of Central Park there, and they would tell you frequently that, well, planets might be very rare, right? Because there were theories of how you make planets that involve very improbable events, and it could be that our solar system could be the only solar system in the whole galaxy. I mean, that was a possibility when I was a kid. Well, it's not a possibility anymore. As you point out, the Kepler Space Telescope, NASA's Kepler Space Telescope, has found, thousands and thousands of planets. But that's actually not the most interesting thing. The most interesting thing is the fact that they now have established that essentially 70, 80, 90% of all stars have planets. And it could be a higher percentage than that even. So that's for an astronomer saying 70 or 80%, that's the same as saying all, right? So essentially, you look up in the sky, you see all these stars. Now, most of the stars you see are not the really interesting ones, but all those stars up there, most of them have planets. That's something we didn't know. Even 10 years ago, we didn't know that. So that gives hope to those of us who are looking for signals.
Okay, now let's be very specific. The closest star to our sun is Proxima Centauri, a triple star system. And it was just announced last year that there is an Earth-like planet revolving around the closest star to the planet Earth. Isn't that remarkable? And then the question is, well, has anyone searched for radio signals from Proxima Centauri B?
Yeah, well, yes, it is remarkable, but maybe it's not. I mean, the estimate is now, and you know, this estimate is probably not extremely accurate, but the estimate is that roughly 1 in 5 stars has a planet that might be more or less the same size as Earth and at the right distance from its star, so that you could have liquid oceans and atmospheres and everything else you need for a really decent lifestyle. Well, okay, 1 in 5, and all right, but we kind of won the lottery there, but there weren't that many lottery tickets if it's 1 in 5. That is interesting. The trouble with trying to check out Proxima Centauri B, this nearest planet, is that it's in the southern hemisphere. It's in the southern sky, and all the big telescopes, or most of them anyhow, are in the northern hemisphere where you can't see these guys. So we haven't been able to check it out. Although we did look at it using an antenna in Australia many years ago. We didn't find any signals. But there's another group over at Berkeley called the Breakthrough Listen Project, and they are using the antenna down in Australia themselves, and they have undoubtedly already looked at, or at least collected data on Proxima B, looking for signals. But it is also important to keep in mind that if the Klingons had a SETI project and we're looking at the Earth, they could have looked at the Earth for 4.5 billion years without picking up any radio signals, even though Earth is a perfectly habitable world.
Okay. And also there was an announcement of a star system with 7, count them, 7 Earth-sized planets going around a red dwarf star. I mean, this is incredible, right? This goes against everything we've learned in astronomy books. But has anyone ever tried to make radio contact with 7 Earth-sized planets orbiting a single star?
Yeah, well, that is a really interesting system. It's called the TRAPPIST-1, and that's a very tortured acronym to kind of make a joke for the people in Belgium, the astronomers in Belgium who led the study to find that, because Trappist is a beer in Belgium, and it's also a monastery, which accounts for the fact that it's a beer. But you're right. It has 7 known planets, and they're all 7 of them are roughly the same size as Earth. Now, think of our own solar system. I mean, you have Earth and Venus. They're about the same size. Mars, it's a little smaller, but roughly. But, Mercury's really not the same size as Earth. Jupiter's not the same size as Earth. Here you have 7, and they're very close to one another. They're orbiting this star very tightly, okay, which is a good thing, because it turns out that this is what's called a red dwarf star. It's a very dim bulb. But by being so close to it, they get enough, if you will, warmth from the star that they could have, again, liquid oceans and atmospheres, at least 3 of them. But the deal is, these guys are so close to one another that, if you lived on one of these planets, looked up in the sky, you would see these balls arrayed across the sky, not like looking at the planets in our solar system, where they just look like bright stars. These would look like little spheres in the sky. But not only that, if life sprung up on any of these worlds, it would quickly infect the others, because they're separated by only 1 million miles, which is not much. That's 30 times less than the distance from here to Mars.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to be talking about aliens from outer space, the science behind the Seti Institute in Mountain View, California. These are professional physicists and engineers who dedicated a huge chunk of their life searching for something which may not even exist, or, if we ever make contact with them, would change human history. Our guest today is Dr. Seth Shostak. He got his bachelor's in physics from Princeton University, PhD in astrophysics from Caltech in California, and he's now the director for the Center for SETI Research, and he is with us today. So, Seth, you talked to us a little bit about some of the planets that we've seen orbiting other star systems. Of them, have we found any that really look like the planet Earth, or are they still not quite in the ballpark of what we would consider a habitable planet?
Well, the answer to that, Michio, is that we don't know the answer to that. You find these planets, for example, the way Kepler finds these planets is that they occasionally just, orbit in front of their sun. They're just lined up by happenstance. They happen to, block a little bit of the light from their sun. An Earth-like planet would block 1/1000th of the light coming from the sun. And, we see that dip in the brightness of the star. But what does that tell you about the planet? Well, it tells you how big it is. And when you see it dip the light again, it tells you, what its orbit is. So you have some idea how far it is from the star. And you know something about the star. Well, you put all this info together, and what you do know is, A, how big is it? If it's as big as Jupiter, you can probably say, well, it might not be a very interesting planet for life. But if it's about the same size as Earth, you say, well, that's more interesting. And if it's at the right distance from its star, where you can say it's not going to be too hot, it's not going to be too cold, it's in the so-called Goldilocks zone, then you can say, well, at least, if there's any ocean there, it's not going to boil away or freeze solid. That's about all you know. You don't know if it actually has oceans. You don't know if it has an atmosphere. In very few cases do we have any information about the atmosphere. So at this point, all you can say is these are, likely candidates, but it's not clear whether any of them is very much like the Earth yet. That's hard to find out.
Okay, now let me ask you the key question. We've been scanning the heavens for decades, even though we've only scanned a few thousand so far. The question is, have we found any, even the slightest hint of a signal from an intelligent civilization in outer space?
Well, we haven't. In fact, it goes beyond that. We don't have any compelling evidence for any life beyond Earth. I mean, we've been talking about intelligent aliens, the kind you see in the movies, but we don't even know whether there's pond scum in space, right? Now, there have been claims. In 1996, the big science story of 1996 was that some NASA scientists and a guy at Stanford University claimed they had found the remains of microbes from Mars in a meteorite. Well, that claim is very controversial, and it hasn't convinced many in the science community yet. So, despite the claims, we still don't know if there are microbes in space, let alone clever, aliens who speak perfect colloquial American English. I mean, we just don't know that. All right, and that may sound a little discouraging. I mean, people come up to me at parties and say, "You've been doing this for a while, and you haven't found anything. Maybe you ought to get a job in transmission repair or something." and maybe I should, but. The point is we've looked at very few star systems compared to the amount that you really should look at in order to have a meaningful sample, if you will. So the fact that we haven't found anything so far doesn't discourage me in the slightest. And I bet everybody a cup of Starbucks will find an alien signal within 20 years. And the chief scientist for NASA last year said that she figured we'd find life in the solar system within 20 years. So I think that this is the generation that's going to change the answer.
Okay. Now, the other question you probably get asked a lot is, what are the protocols when we do find a signal? Let's say that somebody at SETI at home has a PC which crunches some of the numbers, and bingo, he found a signal from an intelligent civilization. What are you supposed to do? Are you supposed to go to Congress, the President, the United Nations, the Joint Chiefs of Staff? What do the nations of the world do? Are there any protocols at all?
Well, there are some protocols indeed. And in fact, they were cooked up in the 1980s when it was primarily the United States and the Soviet Union that were doing these kinds of experiments. And there was some concern that, given the international tensions that existed during the Cold War, that whatever country might find a signal would try and monopolize that information. I don't know that this is really a worry in science. I mean, I was never worried that the French and the...
Yeah, okay, well, Seth, we have to take another short commercial break. But after the break, let's talk about the movies. There are a lot of movies out there, many of them featuring aliens from outer space. How realistic are they? Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about the search for intelligent aliens from outer space. With us today is Dr. Seth Shostak. He got his PhD in physics from Princeton, PhD in astrophysics from Caltech, and he's with the Seti Institute in Mountain View, California. Well, where we last left off, we were talking about, well, what happens when the historic day comes and somebody does get a signal, an undisputed intelligent signal from outer space. What do you do? And what do the nations of the world do? Are there any treaties that nations have signed to go about evaluating this? What happens?
Well, in fact, there have been attempts to draft up some, if you will, rules of behavior. They're called protocols, but that sounds kind of malevolent to me. But all they say is, look, if you find a signal, check it out. Well, of course, that's just good science. Secondly, tell everybody. Well, of course, because there's no secrecy here. And three, don't broadcast anything back. Don't respond without international consultation, whatever that means. I don't know what international consultation means. Maybe, check with the Swedish chess team or something. I really don't know. But it doesn't matter because none of this is supported by law. None of it is international law. And the nations of the world don't seem to be very interested in this problem. They've certainly never made some sort of treaty. And I can tell you that on the basis of false alarms that we've had on occasion, what really happens is that as soon as you get a signal, the media know about it because there is no secrecy. People are emailing one another, putting things on their personal blogs. And the newspapers and the TV stations and the radio stations, they all start calling you up and say, hey, what about that signal? That's what actually happens.
Okay. Now, let's go to the movies, because, of course, Hollywood loves aliens, going all the way back even before H.G. Wells and War of the Worlds. Have you seen the movie Arrival, where aliens from outer space come and they have these huge starships hovering over our cities, and then linguists are called in, and there's a mistranslation of a word. The word is either weapons or tools, and that sets off panic among the militaries of the world, and they're about to go to nuclear war against the aliens. Have you seen the movie?
I have, in fact. I did see it. In fact, I wrote something up about it because I thought it was a little different. They didn't come to Earth to level Los Angeles, although those of us here in Northern California really don't have too much objection to that. But no, it was a little different this film.
Yeah. Okay, well, what about the idea that aliens from outer space are going to have linguists on the Earth translate their language? You would expect they've been monitoring us. If they're that advanced, they can come light years to the Earth. They've been monitoring our language, and they can speak perfect English, right? So what is this thing about having linguists and mistranslating words like weapons versus tools?
Yeah, I'm not sure that makes a whole lot of sense because you're perfectly right. I mean, nobody's going to come to Earth blind in the sense that, well, here's a planet. We'll just go land there with our black banana rocket ships and, hover around and try and talk to them with this weird language that gets ink all over our hands. I mean, that's kind of what this idea was,
yeah.
But at least it was a different idea. They will, as you say, they will have been able to pick up our signals from, well, many light years away now. We've been broadcasting high-frequency, high-powered signals since the Second World War, so that's a long time. If they're 30 light years away, they will know about that, and maybe they'll have, looked at our early television and decide they wanted to come to Earth for some reason.
Okay, well, Seth, we have to take another short commercial break, but after the break, we're going to ask yet another question. What happens if they are more advanced than us? And what happens if, well, we're in the way? What happens then? Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we are talking aliens from outer space. We have with us a PhD physicist. He got his bachelor's in physics from Princeton, PhD in astrophysics from Caltech, and now he's with the Seti Institute in Mountain View, California. And we were just talking about the movie Arrival. I personally like the fact that they were a little bit thoughtful. They tried to get into the fact that aliens are not going to speak perfect English, and there could be miscommunications between their culture and our culture. However, at the end of the movie, the militaries of the world get nervous because, well, maybe they're talking about weapons of some sort, and they're about to launch a nuclear war against the aliens. Now, Seth, isn't that stupid? I mean, if they're that advanced that they can travel light years to the Earth, we are going to launch a war against them? I mean, isn't that dumb?
Well, yes, I couldn't agree more. In fact, I was asked recently by, I think it was a reporter, it doesn't matter, said, so what are the Pentagon plans to deal with an alien invasion? Now, I don't know what's going on in the bowels of the Pentagon, but I said, I doubt that there are any plans. I certainly never heard of any, because if they can come here, if they have the technology to come here, they could just do whatever they want to do. And for the rest of it, the best strategy I ever heard in this regard was, if they come here, negotiate. Just to try and negotiate.
Mm-hmm.
I mean, it would be like, it would be like the Incas having a strategy just in case the Spaniards showed up, right? The Spaniards had guns, not very good ones, but they had guns. They had all sorts of stuff. They had horses. They had things like that. And it really didn't matter what the Incas did. So I honestly think in this case it would be a much, much greater gap than between the Incas and the Europeans. It would be an enormous gap, and whatever they want to do, they can do. I will say that in the case of the arrival, it struck me that these guys look like squids. And I kind of made a quick estimate that you could get 2,000 servings of sushi out of every alien. So, I think that the aliens should be worried.
Okay. Well, let me ask you another question. Stephen Hawking, my colleague, has stated that, well, maybe we should not advertise our existence because, like you mentioned, it's like the Aztecs advertising their existence to Cortez. So what do you say to people who do the opposite of SETI, the METI project, who want to advertise our presence to aliens in outer space before we know what their intentions are? What are your thoughts?
Well, I mean, it's very hard to argue that, no, the aliens are all going to be, sweetness and light, singing Kumbaya, and they're only coming here to help us and that kind of thing. I mean, who knows? Nobody knows, right? And it's not entirely impossible. It's not impossible at all that maybe some fraction of them are aggressive. And so, yeah, maybe there's some danger. But I don't worry about it, not because I believe that all aliens are peace-loving. I mean, I have no idea. But it is true that we've been broadcasting since the Second World War with our radar, mostly radar. And you could say, oh, well, yeah, but that's a pretty weak signal all in all. Well, it is for us. But any aliens that could come here are going to have bigger antennas than we do. Our antennas have been getting bigger by 2 orders of magnitude every century on average. So, they're going to have antennas that can easily pick up all that stuff. So that horse has left the barn. You can worry about advertising the aliens by broadcasting our personal philosophies in the direction of the sky, but we've been doing that anyhow since the Second World War, and I, for one, am not in favor of shutting down the radars at the JFK airport. That doesn't strike me as a good idea.
Okay, now let me ask you another question. You're a physicist. I'm a physicist. We have, of course, objective statements to make to the public. However, in your heart of hearts, what do you think is out there? First of all, do intelligent beings exist in outer space? B, can they reach us? And if they do reach us, are they going to be peaceful? What are your thoughts? Like late at night when you think about this.
Yeah, well, late at night, I hardly think of much of anything. But I will say that the idea that you get from the movies, that they're somewhat like us, although they don't look the same, but they're somewhat like us, that's a little bit naive. If you consider what we're doing in this century, we're doing a lot of interesting things in this century. We're finally understanding biology and so forth and so on. But also, we're developing machines that have cognitive abilities comparable to our own, artificial intelligence, and not just artificial intelligence that can play Go or poker or chess or any of these things, but artificial intelligence that can do anything that a human brain can do. And in that sense, we're really inventing our successors. The aliens, the ones we're likely to hear from, if they're even 1,000 years beyond us or 100 years beyond us, they will have those machines too. So I think that the majority of the intelligence in the cosmos is likely to be synthetic intelligence, not soft, squishy biological intelligence. And consequently, I suppose we should be looking for signals coming from not beings on some sort of planet with oceans and atmospheres, but from artificial intelligence, from machines. And that makes our experiment a very much more difficult one because I don't quite know what to do about that.
Mm-hmm. Now, let me ask you the final questions. Well, you probably get a lot of phone calls from people that say, bah, humbug, they're already here. How do I know they're here? Well, I visited a flying saucer the other day myself and went to Venus. So what do you say to people who are very sincere, very honest, but claim that they've already met the aliens? What are your thoughts?
Well, yes, I do hear from them quite frequently. In fact, essentially every day, somebody sends me, photos or whatever. And, I can't say that I know of a single example where I thought these people are just pulling a hoax here. I mean, some people do that, but they, not the ones that have called me. They're all very sincere. They've seen something in the sky. And, they don't understand what it is, so they jump to the conclusion, usually, that it's some sort of alien craft. If they have photos, videos, whatever, I encourage them, send them along. And I take a look at them. But so far, I've never seen anything that convinces me we're being visited. If we are being visited, hey, that's job security for me.
Okay. And is there a website that people can contact your organization?
Absolutely. It's very simple. Seti.org. Seti.org.
Okay. Great. So once again, our special guest today has been Dr. Seth Shostak of the Seti Institute.
Now, profiling the latest cutting-edge developments in science. Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And this hour, we're going to throw the lines open because this hour is your hour. Okay, well, let's move right along to the first listener phone call.
Hi, this is Steve. I'm calling from Tucson, Arizona. I know that hair on our body is essentially a dead organism. When you cut a hair, there's no nerve, yet hair seems to know how long to grow. The hair on my arms does not grow as long as the hair on my head. If I shave the hair on my arm or leg, it only grows back a certain length. How does the hair know how long to grow? Thank you.
Well, this is a question that could spawn a multi-billion-dollar industry because we're now beginning to understand the genetics and the biochemistry behind the balding process. And think about that. I mean, once we solve balding, there's going to be a tremendous industry set up. Well, first of all, you're right about hair. If you take a piece of hair and put it under a microscope, you don't see cells with nuclei. It doesn't grow like ordinary cells. It's basically pure protein. Yes, that's what your hair is made out of, pure protein. It's not digestible, of course, but it is pure protein. And what governs the growth of a hair? The follicle at the base. And so when some people are going bald, they ask the question, well, when hair falls out, does it grow back? Well, yes and no. First of all, hair grows back pretty much all the time, especially when we're young. And when hair falls out, in fact, we have quite a bit of hair that falls out, 50 or so strands over a period of a few days will fall out of the hair naturally. The new hair keeps on growing to compensate from that. So new hair constantly grows even as old hair falls out. So when hair reaches a certain distance, then the follicle says to itself, okay, time to fall out, and the hair falls out. Now, why is this going to generate a multi-billion-dollar industry? Because we're now finding the stem cells in the follicles which govern the growth of hair. Once we find stem cells, well, stem cells are the mother of all cells. For example, when you have a salamander and you grab it by the arm or leg, sometimes the salamander simply wrenches itself and you're left holding an arm or a leg, but the salamander scampers off into the pond. And later, the salamander's arm or leg grows back. Well, scientists have figured it out. It's the stem cells. It's the stem cells that are still left in the stump that regrows an entire organ. Now, reptiles can do this, amphibians can do this, but we mammals have lost that capability. However, is it possible to revive it? Yes. And that's what some scientists are working on right now. the ability of stem cells to regenerate whole organs. And think about that. Stem cells have been found in the follicle of ordinary hair, which means that even if the hair falls out, one day we might be able to stimulate the stem cells so they regenerate an entire head of hair. And that, of course, could change the whole cosmetics department of your supermarket. And so this is something that scientists are very much interested in. Also on the internet, there is a rather stunning video that you can download. It's a video of a mouse heart. A mouse heart, first of all, that's been separated from the mouse, and stem cells are put inside a cavity, an empty cavity, and over time, stem cells grow into the cavity, creating the tissue of a heart, and then all of a sudden, the heart starts to beat right on the video. It is breathtaking. You realize that you almost feel like playing God, watching stem cells, which are then placed in a scaffolding, grow into the scaffolding, grow into a mouse heart, and then start beating. And so, yes, one day we'll be able to harness this technology. Now, you've probably seen on television and radio ads for stem cell this, stem cell this. I have to say, most of those claims are bogus. I mean, they're just fake. If you follow the research in stem cells, you realize that it's slow, tedious. There are no breakthroughs. We're not going to be able to grow arms or legs anytime soon with stem cells. The promise is there. But, hey, the devil is in the details, and the details have not been worked out. So if you see an advertisement for stem cells to do this and regenerate that, I would hold back, and I would say, well, let me check that out on the internet. And chances are you'll find out that a lot of these claims are actually bogus. So, a word to the wise. The promise is definitely there, but the reality is not quite there yet. Okay, let's move right along to the next listener phone call.
Hello, my name is Roger. I'm calling from Bradenton, Florida, 12:80 a.m. I was just wondering, when you see some sort of explosion, fireworks and different things, the particles go out in every direction, kind of equally. So in any explosion, you can see the center of it. And I've just been reading lately on the so-called, this Big Bang, that there really is no, it was an explosion, I suppose, of some sort, but I've read that there really isn't a center of the universe where that happened. And I'm just wondering how you would explain that.
Well, that's a key question. In fact, the question is so vital that a monk was burned alive in the streets of Rome in the year 1600 because he said the universe had no center. The man's name was Giordano Bruno. The year was 1600. He claimed that all the stars in the heavens, well, they have planets going around them, and that the universe was infinite, uniform, and therefore had no center. Well, the Catholic Church was not happy at all, because if every planet has stars going around it, do they have a Jesus Christ? Do they have the sacraments? Do they have sin? Do they have the Trinity? Do they have the Pope? Do they have the saints? I mean, he goes on and on and on. 1 billion Jesus Christ, 1 trillion popes. The mind just goes crazy thinking about this. And then the universe had no center, he said. And that meant that the church was not the center of the universe, and neither was the earth. Well, this was too much for the church. And so what do they do? Instead of confronting the ideas, they simply burned him alive. And 30 years later, Galileo was being put into the same situation, and he was told, do you realize that about 30 years ago we burned your predecessor alive in the streets of Rome? Well, Galileo was no fool, and he quickly recanted all the incredible discoveries that he made with his telescope. So, now let me give you the modern-day approach to this whole question. We think that the universe is a bubble of some sort. The bubble exploded 13.8 billion years ago, and the bubble's been expanding ever since, and we live on the skin of the bubble. So if you live on the skin of a bubble, you ask yourself a simple question. Where is the center of the bubble? Well, if you're on the skin of the bubble, and you can only move around the skin of the bubble, then you cannot reach the center. The center, in some sense, is in the third dimension. And so if you want to know where the center of the expansion of the universe was, in some sense, it's hyperspace. But in our universe, in our bubble, in our skin of the bubble, you cannot point to any one particular point on the skin of the bubble and say, aha, that's the center of the universe. In other words, the universe was very small back then. Space itself was being created. And that's why the universe had no center, because the universe was very small back then. In fact, the universe was so small in principle, you could put it in your pocket. So with the universe being so small, everything was pretty much at the center. And so where's the center of the universe? It's in hyperspace, another dimension. It's not on the surface of our universe. Our universe looks uniform. But if we had a center of the universe would be denser toward the center, just like when you see fireworks, right? The densest part of the explosion is near the center. We see a uniform universe. Everywhere we look, we see that the universe seems to be uniform with no center at all. Now, the idea of hyperspace sounds bizarre to a lot of people, but think about it for a moment. Our universe is three-dimensional. I mean, everybody knows that. Length, width, height determines every object in the universe. When you say time as well, then every event in the universe can be described by 4 numbers. I live in New York. If you want to have someone for lunch, you say, meet me on 5th Avenue and 42nd Street on the 10th floor at noontime. 4 numbers allows you to specify one event, one unique event in the entire universe. But the question is, why? Why should it be 3 dimensions of space? String theory, which is what I work on professionally, says the universe is 10, maybe 11-dimensional. And there were other dimensions that were created at the instant of the Big Bang. We don't see these dimensions anymore because the universe has curled up these other dimensions, but our universe was actually coexisting with other universes. Now, the new wrinkle coming from string theory is that, yes, our universe is a bubble of some sort, but there are other bubbles out there. And so the multiverse of universes obviously had no center. Each bubble has no center, and the multiverse also has no center. Now, string theory, I should caution, has not been experimentally verified. It's just a theory. However, it is the dominant theory in theoretical physics now. You can go to any university on the planet Earth, talk to the leading cosmologists, and they'll say, yes, 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 string theory is one of the leading, if not the leading candidate for a theory of the origin of the universe. And so to answer your question really simply, the universe has no center. The center, if you really want to point to it, would be in hyperspace, but that's another dimension, a dimension that we three-dimensional beings cannot visualize. Sorry about that. Okay, well, let's move right along to the next listener phone call.
Hello, Professor. My name is Rick. I'm calling from Alabama, station 106.5, and I was wondering what your thoughts were on time travel, and do you think it would be possible, in your own opinion, to go back in time and see relevant events? And if that is possible, could we possibly go into the future where the events have not yet been decided or seen? Thank you.
Okay, first of all, yes, we physicists have looked at time travel very carefully. First of all, time travel to the future is not so hard. We do it all the time. And our astronauts even do it even better. They go a fraction of a second into the future by rocketing into outer space, and time slows down inside their space capsule. But to really go backwards in time, going back to the dinosaur era or something like that, that may actually also be possible using Einstein's equations. Now, Einstein had 2 theories. The first theory, special theory of relativity, would say no. You cannot go backwards in time. You cannot go faster than the speed of light, period. But Einstein was not satisfied with that theory because gravity was missing. And when Einstein came out 10 years later with the theory of gravity, he said that space and time is like a trampoline net. But a trampoline net can do more than warp. It can also rip. And that's what Einstein thought about very deeply. His equations allow for time travel. That doesn't mean that time travel exists. It just means they are valid solutions of Einstein's equations. For example, Einstein's next-door neighbor at Princeton was one of the greatest mathematicians of the century, Kurt Gödel. And Kurt Gödel, being the mathematician he was, found a solution of Einstein's equation which allowed for time travel. If the universe rotated and you went around the center of the universe, then you could come back yesterday. You could go backwards in time. Now, Einstein was very disturbed by this. In his memoirs, Einstein said, yes, my next-door neighbor has just found a solution of my own equations which allow for time travel. But then he said, on physical grounds, I can dismiss it. In other words, the universe expands, it doesn't rotate. Now, the universe expands because of the Big Bang Theory. However, if the universe rotated, then it means that time travel could become commonplace. Well, in the decades since then, we've discovered black hole solutions. Some of these black hole solutions allow for time travel. Then this whole question becomes of paramount importance. If I have a wormhole, a gateway through space and time, a rip through the fabric of space-time itself, on the other end of the wormhole could be the past. This is a valid solution of Einstein's equations. So what's the catch? There's always a catch someplace, right? Well, first of all, to create this hole in space, you need a black hole. And not everyone has a black hole ready. But the other condition I'll get to after the commercial break. So after the commercial break, I will try to answer the question, can you go backwards in time and meet your teenage mother before you're born and have her fall in love with you? What happens then? We'll answer that after the break. Welcome back to Science Fantastic with Professor Michio Kaku. Once again on Science Fantastic, we are awaiting your phone call. Well, before the break, we had a call about time travel. First of all, yes, Einstein's equations do allow for time travel. Einstein himself realized this and mentioned it in his memoirs. However, there's a catch. To create a wormhole, to go backwards in time, first you need enormous amounts of positive energy in the form of a black hole. That's quite difficult to manipulate. We on Earth can barely manipulate dirt, let alone a black hole in outer space. Second, the black hole could crush you as you go through it. You need something called negative matter, or negative energy, to keep the mouth of the gateway open. So far, we've seen no evidence of negative matter. We do find negative energy in the laboratory, however, but in minuscule quantities. You have to have large quantities of negative energy to drive the time machine. So let's say now you go through the time machine. Let's say you're very advanced in your technology. You have enough positive and negative energy to stabilize the black hole, stabilize the wormhole, and you go through it. Let's say you go back to the past. What happens if you shoot your parents before you're born? Well, first of all, time is a river. Newton would say that time is a straight river, never deviates. 1 second here is the same as 1 second on the sun. Einstein says, no, the river of time is a river that meanders. It slows down and speeds up. The new wrinkle on all this is string theory says that the river of time can have whirlpools, and the river of time can fork into two rivers. And that's how you would explain away all the paradoxes of going backwards in time and killing your parents before you're born. When you go backwards in time, you enter a different quantum universe. The timeline splits in half. The timeline has a fork in the road, and a new universe opens up. So when you go backwards in time and meet your teenage mother before you're born, she's not really your teenage mother. She looks like her, she talks like her, has the same DNA as her, but the timeline of the universe has forked, and you are in a parallel universe. Therefore, when you change that person's past, you have not changed your own past. Your own past cannot be changed. That solves all the paradoxes of time travel. All the paradoxes of time travel involve going backwards in time and changing the past so that the present cannot exist. But as I said, the universe splits in half. This is called the many worlds theory, which is now the dominant interpretation of quantum mechanics, which in turn makes possible transistors, televisions, electronics, the computer revolution. Everything we see around us in a laboratory and in your living room is a byproduct of the quantum theory. And the quantum theory has a very simple answer to the paradoxes of time travel. You cannot change your own past. You can change somebody else's past. So that if you go backwards in time, meet Abraham Lincoln at the Ford Theater, and prevent John Wilkes Booth from assassinating Abraham Lincoln, well, your Abraham Lincoln did die. But another Abraham Lincoln was saved, and you've now made it into the history books of another Abraham Lincoln. Well, let's move right on to the next listener phone call.
Hello, Dr. Kaku. This is Richard from Dallas. I'm just calling in regards to a question in science. I was wondering, sir, if you think that cold fusion is even feasible. Thank you.
Well, you ask a question that I often get about cold fusion. First of all, what is fusion? Why is it cold? And does cold fusion make any sense? Well, first of all, fusion is a secret of the stars. Children ask the question, Mommy, Daddy, what makes the sun shine? What makes the stars shine? And the answer is fusion, the process by which we heat up hydrogen to millions of degrees. Hydrogen then coalesces into helium, releasing energy via Einstein's equation E equals mc squared. So the engine of the stars is fusion. Now, of course, we would like to import that to the planet Earth, because fission reactors that use uranium are very messy. When you split the uranium atom, it creates a lot of nuclear waste, and that waste is hot. And that waste, in turn, can create meltdowns. In fact, that's where the heat of meltdowns comes from. So fusion would be clean. It uses seawater, the hydrogen from seawater, as its basic fuel. It would be basically non-polluting. And basically, you would have energy for free. Wouldn't that be great? So several decades ago, two electrochemists said that in a glass of water, they can put palladium. Palladium metal somehow squeezes the hydrogen together to create fusion in a bottle. Well, that created headlines. Everyone was saying, what? Free energy? Energy for free? This is going to change world history. They're going to be bigger than Edison. They're going to be bigger than Rockefeller with this discovery. Well, then the scientists came in and said, not so fast, not so fast. First of all, there's no physical basis for thinking that you can get palladium rods to squeeze hydrogen to the point you get fusion. Second of all, the fusion process releases neutrons. In fact, so many neutrons that Pons and Fleischmann, these two electrochemists, should have been killed by their own device. So in other words, the very fact that Pons and Fleischmann were still alive meant that it was a hoax of some sort. But then later, some people said, now wait a minute, we can reproduce fusion in a bottle in our laboratory. And then began the controversy. On one hand, we had the physicists who said, bah, humbug, this violates quantum mechanics. It violates everything we know about fusion. On the other hand, we have people who were saying, the proof is in the pudding. You figure it out. Here's a device which can duplicate the Pons and Fleischmann result. Well, then it enters Act 3 of this very interesting play. In Act 3 of this play, on one hand, as I said, we have the physicists on one hand, and the inventors on the other hand, claiming that they could do it in the laboratory. Then the question is reproducibility. Toyota gets involved, and they're going to put up $1 million to test this theory. But you see, when Toyota makes a car, they want to make sure that your car starts up every time, not just 1%, but every single time. And reproducibility is where things started to get hairy. Many of the experiments that could be done in one laboratory could not be done in the next laboratory. And then someone went through old patent records in Germany, and they found that a German inventor, over 100 years ago, had a patent for exactly that device. It was a cigarette lighter. A cigarette lighter that used palladium in water to light cigarettes. and that was a patent for a cigarette lighter. So, where are we today? Well, not much has changed, because we still have physicists who say, bah, humbug, it violates the laws of quantum mechanics, and we still do not have a reproducible, that's the key word, reproducible, theory of cold fusion that can be used in your car to start your car or to solve the energy crisis. So that's where we are today. Yes, people still believe in it. Yes, I get emails from people who still believe in it, but hey, it's not reproducible yet. In other words, it's not ready for prime time. So let's move right along to the next listener phone call.
My name is Randy. I live in Fairbanks, Alaska. And my question is, if I'm standing at one spot and I look up in the sky at night, and then I look straight out to a horizon, no matter what direction, how far am I seeing? How many light years am I seeing the furthest star that my eyes can see? Also put that in miles. How many miles am I actually seeing?
Well, when you look at the night sky, you're looking at stars that are in the neighborhood of a few hundred light years away. The nearest star, which you can see from the southern hemisphere, is Alpha Centauri and the Alpha Centauri star system. It's a triple star system. But many of the stars you see at night are 100, 200, 300 light years distant on average. And you wanted to know how's that in miles. Well, every light year is about 6 trillion miles. So just multiply by 6. And then you have in trillions of miles how far that star is. So if a star is 100 light years away, it is 600 trillion miles away. And then what is the farthest object you can see? Well, if you have very good eyes and you look at the constellation Andromeda, you can see a slight smudge in Andromeda, very clearly visible by binoculars, sometimes visible by the naked eye. And when you look at Andromeda, it is 2 million light years away. It is another galaxy about 2 million light years away. And that's about as far as you can see with the naked eye. And so the universe is quite big. Again, the night sky is full of stars hundreds of light years away in our galaxy. But if you look at another galaxy, Andromeda could be clearly visible in the constellation Andromeda, and that's 2 million light years away. And multiply that by 6 trillion, and you have that in miles. Okay, let's move right along to the next listener phone call.
Hi, isn't time simply the movement of things? If you freeze the movement, don't you freeze time? So my question is time simply movement?
Well, I think you're very close. Some philosophers have claimed that time doesn't exist, which I don't particularly believe in. They say that the past is gone. The past doesn't exist anymore, obviously. The future doesn't exist because it hasn't happened yet. And the present, well, is the present plus or minus 1 second, plus or minus a half a second? How thin do you slice a salami to calculate the present? And they would say that, well, the present is infinitely thin, therefore, there's no such thing as time. Well, I don't believe in that. First of all, look at the works of Shakespeare for inspiration. Shakespeare once said that all the world is a stage and that we are actors and actresses making our entrances and exits on the stage. Well, that's pretty close. A stage is an arena in which things happen. Time is a measurement of change in that arena. So if you want to describe events on the stage of life, you need 3 dimensions to locate the position of that object and 1 dimension of time to measure the change in that object. So what is time? Time measures change, or as you pointed out, measures motion. It does exist. It doesn't exist in the sense of a rock. It exists in the sense that when a rock changes, it is the parameter which allows you to measure that change. Now, along comes Einstein, who says that the arena of Shakespeare is actually warped. When you try to walk across the stage, you can't because the ground underneath you is warped. And so space-time now can become a warped sheet of paper. So, yes, time exists. Yes, time could be warped. And yes, Einstein was right. Okay, let's move right along now to the next listener phone call.
Yeah, this is Jason from New York.
my question was, what happened in human history that made the Asian varieties of human beings and, the Easterners to have slanty eyes? What caused them to evolve that way?
Well, the answer is the epicanthic fold comes as a byproduct of the last ice age. First of all, roughly 70,000 years ago, according to archaeological and DNA evidence, modern humans not only walked the surface of the earth, but left Africa. In fact, a handful of us, a few hundred, maybe a few thousand, that's all that was left because some catastrophic event happened 70,000 years ago, probably the eruption of the Toba volcano in Indonesia. Anyway, a handful of us managed to just barely get out of Africa in time. We went to the Middle East, then we went north into where it is now close to Russia, and then we split. Some of us went back to Europe and colonized northern Europe. The other group kept on going east, and they became the Asian people. Now, of course, there was not one but several routes, but this is one of the main routes that took place dating back 70,000 years. And it was roughly 30,000 or so years that this split took place. And the group that went into the Asian peninsula had to deal with the Ice Age. Now, the Ice Age, of course, had winds. This is a theory. We're not sure it's correct. But blizzards and winds, and you have to have a fold in your eye to protect yourself against the Ice Age. And so there's a theory that says that the epicanthic fold was a defense against the horrible winds during the Ice Age. Now, if you want to actually see the routes taken by humanity out of Africa dating back about 70,000 years ago, go to the National Geographic website, look under Spencer Wells, who we've interviewed on radio, and you can actually see these ancient routes out of Africa and date them. And you can actually find out where your ancestors are on this chart thousands, tens of thousands of years ago, going back to the last Ice Age.